Alright guys, so welcome back here. So now in the next video here, I want to start coding some contracts here, okay? So what we're going to do here is, first off, I want to go in my top little tab here, in the Files tab, and I'm going to make a new file by clicking on this button right here. Now we kind of glossed over this in the first video here, so if you guys aren't too familiar, be sure to go back and watch that, but we did go through it kind of fast. So that was just kind of like a preview, but this is going to be a little more in-depth, okay? So I'm going to click on this right here, I'm going to say make a new file, and let's just call this test.sol. Now, off the bat here, a couple things to understand here. I want to go back in one of these other sample contracts from here, or you could type it out, it doesn't really matter from here. And I'm going to highlight these first two lines of code. Actually, I guess technically first three here. And I'm going to paste them right in here. So we kind of talked about this before, but keep in mind that because of the nature of the blockchain here, the code itself here needs to explicitly state what compiler it wants to use. Because of updates, because of things changing from here, if I have the same code being run through a different version of the compiler, sometimes it can result in a different output, okay? And we're going to talk about that a little bit more in this lesson from here, but just do know that from here. So this right here, pragma solidity greater than or equal to 0.7.0 or less than 0.9.0. If we go over to this tab right here, we can see we have a whole bunch of different compilers. So basically what this is saying from here, it's saying, hey, you can use a version that's greater, or I want you to use a version that's greater than 7, but still less than 9 here. If it's greater than 9 here, go ahead and roll it back here, but that's the version I want you to use within that range from there. You may also see it where it's just something explicitly stated like that. You may also see just, the version itself stated here. That's all code, whoops, like that. That's all good to go here. But this is the way I'm going to roll with it right now, okay? So what I'm going to do, also let's talk about this from here. We kind of talked about this before here, but keep in mind that it likes to see some sort of license identifier from here. If I get rid of this here, and I Control-S, Control-Save here, it's not a big deal here, because this is warning. It's kind of ugly, it's kind of in the way here. So I like to have that right there, okay? And then save. Now you'll notice it changed here, right? You see this little thing, if I change, I don't know, let's just change something real quick here. We have this blue circle here. That means that the contract itself is not compiled, it's not saved yet. So if I hit Control-S here, now it's saved, now it's good to go here. Now what I like to do is I like to turn on auto compile from here, and I'll turn on enable optimization too. And what that does is if I make a change from here, let's say I mess something up here, it's going to immediately tell me, it's going to kind of save and compile the contract automatically here, and it's going to let me know if there's any errors. Whereas before, whoops, if I turn this off here, then I have to save it first to see if there's any errors. So I like to keep that on from there, okay? Now just because, actually let's save, we'll touch on this right now. Just because a contract is compiled, that doesn't mean it's deployed to the blockchain. There's two different steps there, okay? So this tab right here, let's start with this one. This one has to do with compiling. So essentially taking our code and mixing it down to the bits and bytes and everything like that here. This right here basically takes our code, takes the bits and bytes from here, and publishes it to the blockchain, okay? So again, kind of keep that in mind here, put a tab, and then we'll be back here in a second from here. We can actually go back wherever we want to. Let's keep it on this one right from here. And let's start writing out a contract. So we're going to say contract, and let's say my contract from here. Now, just like naming a variable, if you guys are used to contract, C or C++ or C# here, you have certain reserved words here, and you have a naming convention from here. So this is saying it's a contract, and this is the name of the contract here. I could make this whatever I wanted to from here. I could make this werewolf if I wanted to. I could make this, I don't know, Dragon Ball, all good from there. I just picked my contract because it seemed kind of easy to keep track of from here. But this is the more or less the variable type, and this is more or less the variable name from there, okay? Even though it's not technically, I guess it kind of could be kind of variable, but it's not really a variable, but anyways, from here. All right, so anyways, from here. Now, what I want to do is let's make a integer from here. So very basic here. We're going to say uint, which stands for unassigned integer. Then we're going to give it a name, let's say num1, and this is going to be equal to 87. 87 is a good number from there. So keep in mind here, if you're coming from a Python background, or maybe even, depending on where your background is, in Python, you just kind of write out your code, and then you can run the script, right? In this case right here, whatever code I want to run has to be within my contract from here. So this is important here. This is more or less the structure that my code's going to take from here, okay? So just keep that in mind, okay? It's also a statically typed language here, which means that if I want a number, I have to say I want a uint number from here. All right, dynamically typed languages are more like your JavaScript here, where you just say let num1, and it kind of figures out on the fly here. In this case right here, I need to have it statically typed, okay? If you want to look more into static versus dynamically typed languages, I encourage you guys to do so if you're more cool. So now what I want to do from here is, this looks pretty good for me here, very basic, but that's okay. I'm going to go ahead and save this from here, even though I already saved, but you can kind of see it refresh for a second there. I'm going to go to this bottom tab from here, and I'm going to find my contract on the contracts. A lot of times it kind of sees it by default, but just make sure that you select that right from there. Now what we have here, and again, I kind of talked about this in the first video, but I want to mention again here, we have a virtual blockchain running in my browser. So it's kind of like a test blockchain from here. I have all these different accounts from here that I can use to send Ether back and forth, send transactions. So this is kind of like my playground per se here. Keep in mind that if I remove, like I'm in a guest mode right now, so once I close this window here, all the information is going to go away here. This isn't like if you're used to Truffle or something like that there, it's not necessarily saved to the device here, it's saved to the browser. So just keep that in mind. If you go out and clear cookies and stuff like that here, you're going to lose your information. That's one of the downsides of having an online IDE here. But you could always download the workspace like we talked about before. Download the workspace. Where'd it go? Workspaces. That's okay. That's just a little tangent from there. Anyways, from here, back to this tab from here, I want to take this contract and I want to deploy it from here. So it's compiled because we have this little green check mark from here. I'm going to make sure, keep an eye on this account from here. If I deploy this contract, now we have this contract right from here. And you can see it costs me a little bit of money from here. As you guys know here, any transaction within the blockchain is going to cost me a little bit of fees because there are gas fees, right? Other computers, other nodes in the network, they need their fees. And that's kind of what keeps the ecosystem up and running, okay? Now we're really focused on Solidity here, but you can't really talk exclusively about Solidity without talking about the blockchain itself here, and et cetera, okay? But anyways, my point being there is I want to get back to Solidity. I don't want to talk about too much about gas fees and stuff like that here because you can go on for hours just understanding the gas fees and proof of work versus proof of stake and stuff like that there. Definitely encourage you guys to talk about that, but right now we're focused on Solidity. Cool. So if I drop down, I had this deploy contract thing here. If I drop this down here, I really don't have that much information. I have an address here, which is the same address. This is basically my console from here. This says, yeah, we deploy the contract successfully here, but I can't really do anything, right? If I want to be able to see this number, I'm going to put the word public in front. Now, again, I come from a C background here, so this was really weird to me at first here. In a C background, you usually say something like public int, and you say A equals 87 here. And you can see we already have an error because, well, first off, it needs to be a uint here. Uint like that here. But we have an error from there. And the reason why is because the function variable structure modified declaration is expected from here. So that means we need to put public right there. So the type, actually, I really messed this up now. So the type comes first, then the visibility, and then the name from there, okay? The syntax is a little bit different, but that's how they do it in Solidity, which kind of makes more sense if you think about it. But anyways, from here, let's go ahead and remove this from here. We'll just keep num1 for right now, okay? I'm going to save this again here. I'm going to go back to this tab from here. I can get rid of my old contract either by trashing it or exiting it. It really doesn't matter right now. If I hit deploy, we can see that if we drop this down, now I can find this number from here. I can look up this number with this button right from there. So I'm able to get information from the deployed smart contract. You may be thinking, like, what's the point of this here? Well, keep in mind, because of the nature of the blockchain here, if this was a real blockchain, I would have this number living in the blockchain for all the blockchain's life, more or less basically for eternity or however long the blockchain lasts for. So this is actually a good way to store information because if I just have a script, let's pretend it's some crazy computational algorithm or something like that, or really some really important number, and I just save it to my computer. Well, what good is that? Because my hard drive can crash. Other people can't use a script there. It's still centralized. If I have a script and I deploy it to a server, again, if that server goes down or maybe it's banned or something like that here, that information is lost here. In this case from here, it's always on the blockchain from here. Anybody with this address could look up this number from here. Now, again, this is kind of silly because it's just a 2-digit number from here and the address is, kind of long here. But, you have to think about it more conceptually than just what you see in front of you right there. A comparison I make here, imagine like back in like the early 80s or maybe even late 70s, trying to communicate to somebody what the internet was. It's like, well, I have some information here and I can send it to my friend here. People would be saying like, well, why don't you just call them up? Why don't you just send a letter? Well, this can do that. Like, it's difficult. Like, you can't think too narrowly. You have to think a little more broad with this information from here. But anyways, I digress from here. Let's do another one from here. Let's say uint public. Let's make a num2. Now, do keep in mind here that we can't have decimals. If I try to make a decimal, we're going to have an error from there. So only whole numbers, which would be an integer, okay? There are ways to work around decimals. We'll talk about that more later on here. But right now, let's just deal with whole numbers. Another thing to keep in mind here is I can't make it a negative number from here. I'm going to get an error, okay? Again, of course, there's ways to work around with these numbers here. But for right now, let's just make it public, okay? Save, and again, we'll close out this old contract and deploy it. And we see it now we have two numbers here. We have num1 and we have num2 from there, okay? And we can interact with these numbers if we wanted to, right? We can look them up with this from here, all right? And again, keep in mind here that it doesn't just have to be me looking this up here. I can send my friend this address right here, then they can look up this information there too, okay? Now, what I want to do here is I want to show you guys something. Let's go like right here. That's fine. We'll leave it there. Why not? Keep it back here. Now, by default, if you look up some older versions of Solidity, you see this uint 256 thing going on here. Uint 256 here. Public num3 equals 15 here. Now, essentially, this is the same thing from here. This is the same thing. Of course, this is num2 and this is num3 here, but this is the same. By default, if you just say uint, it's going to be a uint 256. Now, what is 256? 256 is 256 bytes of memory. Bits. I'm sorry, 256 bits of memory. A bit is a binary digit. Now, if you're thinking about deploying something to the blockchain, if you're thinking about putting information out there, again, it costs fees, right? So the less code, the less computational power they have to use up, the better. So if I had some very small number, I could do a uint 8. I could set this equal to public, and let's say num3, and I could set this equal to 20. Right? Same thing from there. Now, in an 8-bit address here, you guys may be familiar, 8 bits of information can store a number up to 255, okay? And the way that you determine that from there, if I go type in, like, bits to decimal, binary to decimal, same difference, whatever. No, I'm looking for a different link here. Is this the one? Well, no. There was a pretty good link here. Oh, well. Convert. And I don't mean to make this a whole. This might work from here. This might work here. I don't make this a whole lesson on binary versus decimal from here. The more you get into computer science, the more it's going to make sense here. But just so this, so I can connect the lesson from here, we have 8 bits of information from here. So if I go 1, 2, 3, 4, 5, 6, 7, 8, it's going to be 255 from there. 255. Okay. This representing 1. This representing 2, 3, 4, 5, all the way up from here. So if I turn one of these bits off here, this should be 253 from now, right? 253 from there. And basically you add all of them up together from there. Now, why do I say 8? Because I can't type out 256, right? If I sat here and typed out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This is just a 32-bit. And we can see how big of a number that can be here. So you can only imagine how big a 256-bit number would be, But keep in mind here, this can store a very large number. You may also see it where it's a smaller number here. You can do a uint 16, 32. The following number is the amount of bits that this number can hold, how big this variable is per se, okay? Now, do keep in mind here, again, if I do uint 8, and I say something like 256, it's not allowing me to do it. It knows that there's an error from here. It's basically an out-of-range thing, okay? So 255 is as high as that can go from there. I'm actually kind of curious now here. Do we have like a highest 256-bit number? Maybe it'll show me on here. There we go. Actually, it's kind of cool here. The highest value is that number right there. So that's the highest a 256-bit number can hold. Pretty cool there. But anyways here, guys, you may be saying, like, again, don't think too narrowly here. You may be saying, well, I just made numbers here. This is so basic. I did this my first day in computer science, or, my middle school coding class from here. Don't think of it just like this here. Think about, number one, you're getting used to the language from here. You're getting used to the syntax, how it's written here. We also talked about contracts from here. We talked about this stuff here, too. We got used to making new files. We also got used to compiling, and we got used to deploying things to blockchain from here. So this is sort of the lesson from here. This is the main core lesson, but all this other accessory stuff is surrounding the lesson from there. Okay, so keep in mind here, you're learning all this stuff too here as we go through, and the more you practice, the better you're going to get at this from here. Okay, and even if you take all this other stuff away from here, it's still good practice. Again, if I just threw you right into the woodwork and we start talking about storage from here and all these numbers, like, whoa, man, what's going on from here? Even this contract right here, uint 256. Now you're familiar with, oh, that means the unassigned integer of 256 of bits of value. Okay. Anyways, guys, I think this video has gone on long enough. I will see you guys in the next one. Great job.